Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to discuss some basic definitions about elements, compounds and mixtures. So important definitions to understand matter are matter. What is matter, students? Anything that occupies space and has mass is called matter. What is mass? Mass is large body of something. Number two is substance. Now, what is substance? Matter having characteristics different from characteristics of other matter is called a substance. For example, oxygen, water, carbon dioxide, urea, glucose, and salt, etc. Number three is element. Now, what is an element? A substance that cannot be converted into other simpler substance is called an element. For example, oxygen, hydrogen, iron, copper, etc. Another definition of an element: a substance whose all atoms have same atomic number. Now, what is an atomic number? Any atom having protons in the nucleus of an atom is called atomic number. Now, what is compound? Compound is a pure substance that consists of two or more elements, and these elements are held together in a fixed proportion by natural force, and this is called chemical bonding. Now, properties of these compounds, they are different from the properties of elements from which they are formed. For example, water, carbon dioxide, copper sulfate, and sodium chloride, etc. They are compounds. Students, two atoms of hydrogen, they combine with one atom of oxygen. In this way, it forms a compound. Number 5 is mixture. Now, what is mixture? An impure substance that contains two or more pure substances, but they retain their own individual chemical characteristics is called mixture. For example, air, water that contains dissolved oxygen, table salt dissolved in water, salt plus sand, etc. Number 6 is heterogeneous mixture. Now, what is heterogeneous mixture? It is a mixture that consists of two or more basically different components is called heterogeneous mixture. For example, sand plus salt. Now, students, if you mix sand and salt, they will not mix with each other. Like the particles of sand and salt, they will be clearly visible to us. Now, the second example is oil floating on water. We will also be able to see clearly that oil floats on water. So these are examples of heterogeneous mixture. Now, what is homogeneous mixture? A mixture that consists of only one phase is called homogeneous mixture. For example, sugar mixed in water, salt dissolved in water. Now, students, if we mix sugar in water, so it will be completely dissolved in water. By this we mean that it is a mixture which consists of only one phase. Like when we mix sugar in water, we will not be able to see sugar in water after some time when we mix it. Even if we dissolve salt in water, we will not be able to see salt in water when we mix it. So this is an example of homogeneous mixture. Now, this mixture has uniform composition throughout. Some important points are students that the entire physical world is made up of mixture of elements and compounds. Now, most of its components are made up of molecules.
Now we are going to discuss what is an atomic number. The number of protons in the nucleus of an atom is known as atomic number. For example, one proton in the nucleus of hydrogen atom, that is called atomic number. So it means that its atomic number is 1 because there's only one proton in the nucleus of hydrogen atom. Now, second example with us is that of helium. Helium is having two protons in its nucleus, so its atomic number is 2. Now we come to discuss mass number. Total number of protons and neutrons in the nucleus of an atom. Now, what are isotopes? Isotopes, students, when some atoms of an element they have different number of neutrons, they are known as isotopes. For example, we can have this carbon 14. It is having 8 neutrons. Carbon 13. It is having 7 neutrons, and this carbon 12, it is having 6 neutrons. Students, this 14, 13 and 12, these are the mass numbers. So when we subtract 6 from this 14, we'll have 8 neutrons, and whatsoever is remaining, that will be the number of protons. So these are all isotopes of carbon, students. Thank you.